Hello friends, welcome in a lecture of Mechanics of Solid Subject. Myself Mitesh S. Patel and I am a assistant professor in a mechanical department at a Dr. Subhas Technical Campus, Junagadh. Today's our lecture topic is a moment of inertia. So in this lecture we discuss uh, what is the inertia, then what is the moment of inertia, what is the area of inertia, what is the mass moment of inertia, and we see the parallel axis theorem, perpendicular axis theorems related to moment of inertia, and also see the how to calculate the moment of inertia of regular shapes uh, of rectangle, square, circle, okay, that types of regular shapes, moment of how to calculate the moment of inertia of this regular shape. So let's start this lecture. Okay, so let's see that first what is the inertia. First see the term what is the inertia. We all know that what is the inertia. Inertia is the one kind of property of matter that regain its original position if the body is in static condition. That's try to body to in static condition. Again, the if force is applied to the body, then body try to regain its static condition. If the body is in motion condition, then body will to try to continue its motion against the force. એટલે કે બોડી જો સ્થિર કન્ડિશનમાં હશે અને આપણે એને ફોર્સ આપીને ટ્રાય કરશું મોશનમાં લઈ આવવાની, તો બોડીની જે બોડી એટલે કે બોડીનું જે મટીરિયલ છે એ બોડી ટ્રાય કરશે સ્થિર રહેવાની અગેન્સ્ટ ધ ફોર્સ. એ જે ઓપોઝિશન છે દેટ ઇઝ કોલ્ડ ઇનર્શિયા. અને જો બોડી મોશન કન્ડિશનમાં હશે તો આપણે એને રોકવાની ટ્રાય કરશું તો બોડી મોશનમાં રહેવાની ટ્રાય કરશે. તો ડેટ ઇઝ કોલ્ડ ધ ધીસ કાઇન્ડ ઓફ પ્રોપર્ટી ઓફ મેટર, એટલે કે મટીરિયલની જે કંઈ પણ પ્રોપર્ટી છે દેટ ઇઝ કોલ્ડ ધ inertia. Okay, now what is the moment of inertia? Let's see the example. With the help of this example we discuss the what is the moment of inertia. Okay, let's consider this object. This is the our object. If we will try to twist in this direction to this object, of one end of this object, then this object resists against the twisting. એટલે કે આપણે જો ઓબ્જેક્ટને ટ્વિસ્ટ કરવાની ટ્રાય કરશું તો ઓબ્જેક્ટ ઇઝ રેઝિસ્ટ ટુ અગેન્સ્ટ ધ ટ્વિસ્ટિંગ, એટલે કે રેઝિસ્ટ કરશે ટ્વિસ્ટિંગને. તો ડેટ કાઇન્ડ ઓફ પ્રોપર્ટી ઓફ બોડી ટુ રેઝિસ્ટ અગેન્સ્ટ ધ ટ્વિસ્ટિંગ દેટ ઇઝ કોલ્ડ ધ મોમેન્ટ ઓફ ઇનર્શિયા. એટલે કે જે આપણે મોમેન્ટ આપી એનું રેઝિસ્ટ કરે છે, ધીસ રેઝિસ્ટન્સ પ્રોપર્ટી ઓફ મટીરિયલ to against the moment is called the moment of inertia. Okay, now moment of inertia, basic equation is a mr square, okay, or mk square. How it's come? Well, let's see that we know that force is equal to ma according to Newton's second law of motion. If we consider the one mass, small mass, is rotate about this axis. If we be applying this force F to rotate about this axis, this is the force F we apply to the mass to rotate about this vertical axis, and this is the distance, perpendicular distance of mass from the axis, small r. Okay, now in this equation, left and right side we multiply the r with the r. So r is multiplied by both side, left and right side. Okay, so here now we know that this is the acceleration, but this is the linear acceleration. If we want the rotational acceleration, then relation of linear and rotational acceleration is a linear acceleration is equal to radius into angular acceleration or rotational acceleration. Okay, so here we put the value of linear acceleration in form of rotational acceleration. So r alpha is a rotational acceleration. Okay, here the equation become mr square alpha, and R into F, force into perpendicular distance, is defined by torque. We do very well know that the force into perpendicular distance is a torque, and torque is defined by tau. So here force into perpendicular distance is R, so we can write here torque tau. So tau is equal to mr square alpha, and we know that what is the equation of torque tau is equal to, we can say, write that I alpha. So if we comparing the equation 1 and 2, the value of I is a mr square. Okay, mr square is defined by I. Here in this equation mr square is defined by I. So equation of moment of inertia is a mr square. Okay, now inertia, moment of inertia is a two type. Moment of area, moment of inertia about area, and mass moment of inertia. Area moment of inertia and mass moment of inertia, two types of moment of inertia. First we see the area moment of inertia. Okay, so equation of area moment of inertia is a I is equal to basic moment of inertia equation is a mr square. So but here the area moment of inertia is equation, instead of m, area is here ar square or ak square or al square, means the h is a distance, r is a distance, k is a distance. Okay, so let's see that this equation is derived according to considering the one area. Consider the lamina of area A shown in figure. The uneven area is considered which having area capital A. Okay, as shown in figure is given. Let's the lamina is split up into the infinite number of small element which having a same area of dA. So lamina is converted into the small element of same areas. Same area वाला नाना नाना टुकड़ा में आपने divide करी अब this total area of lamina. Okay, now x1 x2 x3 is a distance of the small elements of this area from OY axis. OY axis થી જે horizontal distance છે બધા small elements ના, that is a x1 x2 x3 to xn. Okay, now y1 y2 3 y3 and yn is a distance of small elements from OX axis. એટલે કે અહીંયા જે small elements છે એનું distance OS axis થી, that is a y1 y2 y3 to yn. Okay, now taking the second moment of all small elements about the OX axis. So moment of inertia of area, okay, it's defined by about x axis, like a horizontal axis, x axis or OX axis. So x axis moment of inertia is defined by Ixx. So Ixx is equal to small area into distance y1 square. Okay, similarly for other element dA into y2 square, distance is y2 for another area. For another area distance is a y3, so dA into y3. Similarly plus 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 dA yn square. Okay, now we know that summation of dA into y square, this equation becomes summation of dA into y square. So summation of dA is equal to, we know that the total summation of dA is equal to the total area of this lamina. So summation of dA is a total area and y square. So this is the equation of moment of inertia of area about x-axis. And for about y-axis, similar procedure. Iyy means considering the OY axis or vertical axis or y-axis. So mass moment of area moment of inertia about y-axis is defined by Iyy. Okay, so Iyy is equal to small area into distance. Horizontal distance is a x1. First small area is considered dA and the distance is x1, so dA x1 square Now another element is considered. It's having a distance x2 and area having the same dA. So dA x2 square. Another element is considered dA, which having a distance x3. So dA into x3 square plus similarly this way plus 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 dA xn square element. Okay. Now equation we can write that summation of dA into x square. Now summation of dA means the total area of lamina, so is a x square. Now this is the equation of area moment of inertia about y axis or vertical axis. Okay. Second moment of area is called the moment of inertia, and the unit of area moment of inertia is a mm square, mm raised to 4 or centimeter raised to 4. Okay. The second moment of area is called the moment of inertia. So unit of moment of inertia is a mm raised to 4 or cm raised to 4. Okay. Clear? Now let's see what is the radius of gyration. Here two consideration is there. Here the small areas, this area is converted into the small elements of same area, dA, and here also same, but here the elements is the different distance, but here the all elements are at the same distance from the AB axis, but here the small elements are at a different distance from the AB axis. These two considerations are there. So let's see, consider lamina is split up into the small element, each having a same area dA. Okay, and the distance r1, r2, r3 from the of a small element from the AB axis. Okay, clear? Now IAB is equal to dA r1 square according to equation dA r1 square, dA r2 square, dA r3 square. Okay, clear? Now IAB means the moment of inertia about AB axis is equal to this small area into distance dA into r1 square, dA into r2 square, dA plus dA into r3 square, plus number of elements are there, then dot 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 dot. Now equation becomes summation of dA r square. Okay, so now let's consider the another conditions. Let individual small elements of lamina be arranged at a same distance k from the axis AB. The distance k being such that the moment of inertia about axis AB remains unchanged. Okay, the distance k being such that the moment of inertia about the AB axis remains unchanged. And એક axis એક એવું distance radius of gyration that is called the k. કેવું ડિસ્ટન્સ મેં ડિફાઇન કરીએ કે જ્યાંથી બધા સેમ ડિસ્ટન્સ ઉપર હોય અને એનાથી મોમેન્ટ ઓફ ઇનર્શિયા છે એ ચેન્જ થાય નહીં અબાઉટ એબી એક્સિસ, જે કન્ડિશન છે એ પ્રમાણે. ઇન ધીસ સેકન્ડ પોઝિશન ઇટ સ્મોલ એલિમેન્ટ્સ એરિયા એટ અ સેમ ડિસ્ટન્સ કે અબાઉટ એબી. એમઆઈ ઓફ લેમિના એટ axis AB, moment of inertia of lamina about axis AB. Okay, so IAB is equal to, for the second condition, here dA into k square, dA into k square, dA into k square, summation of dA into k square. So summation of dA is a capital A, so IAB is equal to AK square, and here IAB is equal to AR square. Okay, so here for the second consideration, K is called the radius of gyration of lamina about axis AB. The distance from the given axis at which if the small elements of the given lamina are placed, the moment of inertia about the given axis does not change. this distance is called the radius of gyration. એક એવું ડિસ્ટન્સ ડિફાઇન કરીએ કે જ્યાંથી બધા સ્મોલ એલિમેન્ટ્સ છે એને એ ડિસ્ટન્સ ઉપર પ્લેસ કરીએ અને મોમેન્ટ ઓફ ઇનર્શિયા ફાઇન્ડ આઉટ કરીએ તો રિમેન્સ સેમ, પહેલાં જેટલું મોમેન્ટ ઓફ ઇનર્શિયા રહે. આ બે કન્ડિશનમાં તમે ચેક કરો તો એક એવું ડિસ્ટન્સમાં ફાઇન્ડ આઉટ કરીએ બધા એલિમેન્ટ માટે સેમ, એવું એક ડિસ્ટન્સ ફાઇન્ડ આઉટ કરીએ દેટ ઇઝ ધ because of that moment of inertia ચેન્જ ન થાય, જે અહીંયા હતું એ જ રહેશે અહીંયા, એવું એક ડિસ્ટન્સ ડિફાઇન કરીએ. દેટ ડિસ્ટન્સ ઇઝ કોલ્ડ ધ રેડિયસ ઓફ ગાયરેક્શન. ઓકે, a k square, and here I is equal to a k square, so the radius of gyration is equal to under root I upon a. So radius of gyration is find out with the help of k is equal to under root I upon a. I is the moment of inertia and upon a is the total area of lamina or whatever body. Okay, let's clear that. Now see the section modulus. Now see, what is the section modulus? It is the ratio of moment of inertia about natural axis upon distance of extreme fiber from the natural axis. Okay, now body having a two axis, two natural axes are there, xx and yy. Okay, so if considering the xx axis, then zxx are there, means the section modulus about x-axis. So moment of inertia about the natural axis mean for xx axis, so moment of inertia about xx axis. એટલે કે જો આપણે સેક્શન મોડ્યુલસ xx axis માટે જોતું હોય તો ફોર ધેટ કન્ડિશન મોમેન્ટ ઓફ ઇનર્શિયા આપણે xx axisનું જોશે. તો મોમેન્ટ ઓફ ઇનર્શિયા ઓફ ixx axis upon distance of extreme fiber from the natural axis, એટલે કે જ્યાં એક્સિસ છે ત્યાંથી extreme distance of fiber means the કેટલું હશે d/2. Okay, so here d/2. Similarly for zyy section modulus about yy axis, so for that we have to consider the yy axis and moment of inertia about y axis iyy, and the distance of extreme fiber from the yy axis is a d/2. So section modulus about xx axis and yy axis ixx upon d/2 and iyy upon d/2. By this way we can calculate the section modulus. And what is the section modulus? It is the ratio of moment of inertia about natural axis upon distance of extreme fiber from the natural axis. It is the ratio of is called the section modulus, and it's defined by capital Z. Okay, so this section modulus, keep it in mind, it is important terms and it's repeated many times in designing subjects and moment of inertia. So section modulus is an important terms, and it's a ratio of moment of inertia about natural axis upon distance of extreme fiber from the natural axis. Okay, now see that first here is there, determine the second moment of area of rectangle or moment of area, second moment of area or inertia of area of rectangle about an axis through the centroid and parallel to base. એટલે કે આપણે મોમેન્ટ ઓફ ઇનર્શિયા ફાઇન્ડ આઉટ કરવાનું છે એરિયા માટે, મોમેન્ટ ઓફ એરિયા ફાઇન્ડ આઉટ કરવાનું છે ફોર અ ગિવન રેક્ટેંગલ. રેક્ટેંગલ માટે અબાઉટ એક્સિસ એટલે કે એક્સિસ થ્રુ અને એન્ડ પેરેલલ ટુ બેઝ એટલે કે બેઝથી પણ ફાઇન્ડ આઉટ કરવાનું છે, બેઝથી અને એક્સિસથી. બરાબર છે. નાવ કન્સિડર ધ રેક્ટેંગલ, અહીંયા આપણને કીધું છે બેઝથી પણ ફાઇન્ડ આઉટ કરવાનું છે. હવે કન્સિડર કર્યું રેક્ટેંગલ, કન્સિડર ધ રેક્ટેંગલ ઓફ વિડ્થ b એન્ડ ડેપ્થ d. વિડ્થ કેટલી છે b અને ડેપ્થ છે ઊંડાઈ કેટલી છે d. Also consider the small strip of thickness dy at a distance y from the centroidal axis. The centroidal axis is the x-axis. from that y distance dy small strip is considered as shown in figure. બરાબર છે. એક્સએસ એક્સિસથી y ડિસ્ટન્સ ઉપર સ્મોલ સ્ટ્રીપ કન્સિડર કરી dy જેટલી dy થિકનેસની. બરાબર છે. નાવ we know that the second moment of area of strip about x axis is the small area dA into distance square y square. Now the second moment of area of strip dy about x axis, how we calculate that? We know that area into distance. Area is a dA of strip. Area of strip is a dA and distance is a y square. Okay, so dA into y square. Now dA is the area of small strip and integrate between the limits. Now for mi of whole area, now if we calculate the whole moment of inertia of all areas, total areas moment of inertia if we want to find, then integrate that to minus d by 2 d by 2 minus d by 2 to d by 2 this equation. Integrate to this equation from minus d by 2 to d by 2 limits. Okay, so we can calculate the all moment of inertia of all bodies, okay, or of all this area. Okay, so equation become I-axis dAy square. Now integrate this equation for find out the moment of area of this total area. Okay, so limits is given minus d by 2 to plus d by 2. Here the natural axis is a 0, minus d by 2 plus d by 2. Okay, this is the limit. Now what is the area of strip? Is a b into dy. So area become right as a b into dy. Now b is a constant, so it's come out on the integration, so remaining is a y square into dy. Okay, so here dy is right as a dy, not this way. This is the mistake in book. Dy is right this way, not this way. Okay, so y square dy, integration of y square is a y cube upon 3. Okay, and limits is a minus d by 2 to d by 2. So put it this limit in y cube upon 3. So cube of 2 is a 8 into 3 24, and d raised to cube. Similarly minus or negative, we can calculate that plus, it's become a plus. And now finally d cube 2d cube upon 24. Okay, negative plus, and here sum of this d cube upon 24 is a 2d cube upon 24. So 12 into 2 divided by 2 upon 24 is divided by 12. 2, so upon is a 12, and here is the d, and so remaining is the equation is a bd cube by 12. So moment of inertia of the whole area about x-axis is a bd cube by 12 for the rectangle area. Okay, so this is the equation of moment of area about x-axis for rectangle. Okay, similar way we can calculate for the IYY axis. Okay, and here we also have to calculate the moment or second moment of area about the base. Okay, so consider the small strip of thickness dy at a distance y from the base. Okay, આપણે એક્સ એક્સિસથી જોતું હતું એટલે સ્ટ્રીપનું ડિસ્ટન્સ છે ત્યાંથી જ કન્સિડર કરેલું હતું. અત્યારે ઇનર્શિયા આપણે મોમેન્ટ જોઈએ છે બેઝથી, તો આપણે ડિસ્ટન્સ ત્યાંથી કન્સિડર કરશું સ્મોલ સ્ટ્રીપનું વાય ડિસ્ટન્સ ફ્રોમ ધ બેઝ. ઓકે, સો ફ્રોમ ધ બેઝ મોમેન્ટ ઓફ એરિયા is defined by I base, and equation become area into distance square, a into y square, and area become a dA. So dA y square. Now we have to require the inertia of area of whole areas. Like means the second moment of area is required for the total rectangle areas. So for that we have to integrate this equation from limit to 0 to d here, because the basic axis is a 0 is here. Okay, distance is calculated, y is from 0 to base. Okay, so limit is a 0 to total d. Okay, now area of strip is a b into dy. So b is come out on the integration is constant, so y square dy, so y cube upon 3, and if you put the value of limits, the equation become I base is equal to bd cube by 12. Okay, so moment of area for rectangle about base, this equation is for that. Okay, so moment of inertia moment of area about the base for a rectangle is a bd cube by 3. If the moment of area of rectangle about x-axis is a bd cube by 12, okay, and moment of area about y-axis for the rectangle is a db cube by 12. Okay, it's also calculated by this way. Okay, clear? This way we can calculate the all moment of areas about base, about the natural axis or y-axis for the regular sections, for square, for circle, for rectangle. Okay, so let's say directly not calculate the all sides or not derive the moment of inertia for the all shapes, regular shapes. Directly we can see that moment of inertia of regular shape for rectangle. Last we have discussed what is the I-axis about x-axis moment of inertia equation is a bd cube by 12, and for y db cube by 12. Okay, for radius of gyration is find out with the help of under root I upon a. Okay, through this equation we can calculate the radius of gyration of given area, and here is a rectangle, so rectangle is into bd, so bd cube by 12 upon bd in under root. Okay, so radius of gyration is find out with this equation under root I upon a, and section of modulus for rectangle is a bd square upon 6, bd square upon 6. Okay, sorry, here for y a section of modulus about y-axis is a db square by 6, and section of modulus about x-axis is a bd square upon 6. Okay, so this equation you have to memorize to solve out the composite area type examples of moment of inertia. So you have to memorize the moment of inertia equations about x-axis, y-axis of regular shapes like a rectangle, circle, square, quarter circle. Okay, so you have to memorize for triangle, square. For a square, moment of inertia about x-axis is defined by, it's find out with the help of b raised to 4 upon 12, and similarly for about y-axis moment of inertia is find out with the help of b raised to 4 upon 12 for a square. Okay, and now for a hollow rectangle, so moment of inertia is minus the hollow areas, okay, from the total area. For the hollow rectangle, if you find out the moment of inertia for the hollow rectangle, then we find out the total inertia of total rectangle area, and from that minus the inertia of hollow section area. Okay, so equation become for moment of inertia about x-axis is a bd cube minus small bd cube upon 12, and small bd cube is a hollow sections and capital bd cube is a outer sections dimension, okay, breadth and depth. Okay, so through this equation we can find out the moment of inertia of hollow rectangle. Okay, now for a circular area, for that moment of inertia is find out I-axis equal to pi by 64 into d raised to 4. Okay, pi by 64 into d raised to 4. And for a hollow circle, moment of inertia about x-axis is find out with the help of pi by 64 into capital D raised to 4 minus small d raised to 4. Capital D is a outer bigger diameter and small d is a smaller diameter. Okay, similarly for y axis the equation becomes the same. For if moment of inertia for a hollow circle, the equation becomes same, pi upon 64 in bracket d raised to 4 minus small d raised to 4. Okay, so this is the basic shapes which are regularly used in composite area, creating the composite area, and for that we have to find out the moment of inertia of this composite area. So we have to know how to find out the moment of inertia of this regular shape. So this equations it's important, and so it's how to rememberize the all equation of the regular shapes of moment of inertia. I-axis for the right angle triangle, BH cube by 36, B is the width and H is the height of triangle. So BH cube upon 36 about x-axis. If for y-axis it's change H into B cube upon 36. Okay, so moment of inertia about x-axis and y-axis for a right angle triangle. And for the triangle, so similar the equation for x-axis BH cube upon 36 and HB cube upon 48. Okay, and okay, here I base is equal to BH cube upon 12. Here I-axis, IYY, and I-axis and IYY moment of inertia about x-axis and y-axis is similar to the right angle triangle, but the moment of inertia about base for the triangle is BH cube upon 12. It's not that. Okay, so this is the basic equations which are helpful to solve the examples of composite areas. So it's an important equation. So all the equations of moment of inertia for the regular shape you have to know or memorize that. So I hope that you very well understand what is the inertia, what is the moment of inertia, how to calculate the area of moment or moment of inertia of area. Okay, so thank you for listening the lecture. Thanks.